Suppose a bank is planning to determine the positions of ATMs in a specific part of a city. The map is available to us. The bank surveyors aim to position ATMs at crossroads or T-junctions. We refer to all of them as junctions. There are 13 points marked as junctions on the map. These are not junctions, these are curved roads. The rule they adhere to is that anyone at a junction must have access to an ATM either within that junction or at least one adjacent junction. Each junction can accommodate at most one ATM. Therefore, if a person stands at junction D, they should find an ATM in at least one of the junctions A, C, D, E, and H. Also, if an ATM is located at a junction, for instance at junction A, people in junction A, B, C, and D have access to it. Okay, to solve this problem, first we're going to model the map as a graph. We have junctions as vertices and roads as edges, and they give us a simple connected graph. Note that edges are used to represent curved roads. The bank surveyors can place one ATM at each junction, but the cost is so high. Or, as another solution, they can position ATMs in A, E, G, I, and N. In graph theory, set D is termed the dominating set of the graph. That means every vertex of the graph is either in D or adjacent to a vertex in D. As mentioned earlier, vertex A dominates vertices A, B, C, and D, but it doesn't dominate vertex E. By modeling the problem as a graph, and according to this definition, we are looking for a dominating set as the set of ATM's locations. Now, in this set, if we eliminate vertex E from their dominating set, it won't be a dominating set anymore, because there is a vertex such as E or F is two red vertices, which is not adjacent to any of the vertices in the set. Consequently, this set fails to dominate vertices E and F. We may provide several sets as examples of dominating sets, like this, or for example this. And as I mentioned before, the set of all vertices of a graph is also a dominating set of the graphs. But we know that companies naturally prefer to cut costs. So the bank wants to use ATMs as little as possible. Therefore, our task is to identify a dominating set with the minimum number of members. We call that a minimum dominating set. We know that for simple graphs, the degree of a vertex is the number of edges incident with the vertex. For example, the degree of A is 3. We can see that A dominates 4 vertices. Actually, each vertex dominates all adjacent vertices as well as the vertex itself. In this problem, one of the vertices with the maximum degree of the graph is D. and its degree is 4. So it dominates 5 vertices. If you have 2 vertices with degree 4, these 2 vertices probably dominate at most 10 vertices. So we need at least 3 vertices to dominate the graph due to the 13 vertices of the graph. We should explore to find the dominating set with 3 members. By testing some different sets, we may find the set C, F, and L as an answer. It might take some time to check and compare. Consequently, the bank can position ATMs at junctions C, F, and L, fulfilling the specified condition. As another example of a dominating set in graphs, suppose this graph with 9 vertices and a maximum degree of 5 belongs to vertex A. So A dominates 6 vertices, and in this situation we need at least 2 vertices to dominate the graph. By checking the graph, we realize that there isn't any dominating set with 2 members. In fact, dominating sets must have at least one vertex from B, C, and G, at least one vertex from D, E, and H, and also at least one vertex from I and F. So, dominating sets consist of 3 or more vertices. I leave it for you to find a dominating set with the minimum number of members. I hope you enjoyed this video and found the information both valuable and practical. If you have any questions, feel free to leave a comment. Thank you for watching.